Hey guys, it's Mr. Bosher, and in today's video, we're going to talk about domain and range again, but we're going to look at it in terms of graphs, and rather than points, we're going to look at more of lines rather than just a couple of points like we did last time, okay? So this is going to change our answers a bit, and we're going to see how do we tackle that, and yeah, let's go ahead and get started. So at the very top, it says when the domain and or range of a function includes a continuous interval. So let's zoom in there. A continuous interval of numbers, basically like a line. If you kind of peek ahead at 5, 6, and 7 down here, we have like these line segments. Okay, those would be continuous intervals because I have a lot of points rather than only a few points on the graph, and I'll explain that once we get there. Okay, so if I have a continuous interval of numbers, I do not want to have to sit there and write every single number that could be on the line, right? Because I could write 1, 2, 3, 4, and then I could also write like 1.5, 2.5, 1.3, 1.25, right? I have to add in all those decimals too, so I'd be sitting there a long time writing numbers. So rather than just writing the numbers like we did last time in our fancy brackets, we're going to write these in an inequality. Okay, we're going to write them as an inequality. Okay, and an inequality are just these symbols down here, right? Greater than or less than, little alligators. All right, so that's how we're going to write our answers today. But how are we going to do that? Well, let's practice with just a number line. So it says describe in words the values on the number line below, and then we'll try to put it in an inequality just to sort of help us, okay? Before we can really make an answer, though, we need to notice these two things. The difference between these 2 points. One is filled in, and one is left open. Now, in a previous assignment, I believe I gave you sort of a short explanation of what these mean, right? A point that is filled in works like the points that we know and we're used to, right? We can be that number. So because this -4 has a filled in point, that means we can equal -4. We do actually touch the -4 on our number line. But the open one at 3 is open, right? It's not completely filled in, which means that we don't quite get to 3. We get really close to 3, but we never actually touch it. So we are not equal. So if you look over here, we call this included and not included. Okay? Included will give you this filled in point like we're used to, and the main difference is that we have the equals part on our symbols here. So we say that we have less than or equal or greater than or equal. Okay? Now, if it's open and it's not filled in, that means that we lose the equal part. You see how those parts are missing? So we only say less than or greater than. All right, that's the main difference. So when we look over here, I know that I can be equal to -4. So I can be equal to -4, but I will not be equal to +3. So how are we going to write that? Well, let's see. I care about this bold line on the number line, right? You probably have seen this in previous classes from last year. And I want to explain to someone, okay, well, what does that mean? Well, let's look at all the numbers that are on the number line and how they relate to -4. If I look at -3, that's greater than -4. If I look at -2, that's greater than -4. -1 is greater than -4. And all of these numbers are greater than -4. So that's what I'm going to start with. I'm going to say, all right, I'm going to say greater than, oops, there we go, greater than but there's another thing I need to think of here. am I only greater than -4, or can I also be equal to -4? If you remember before, we said because the point is filled in, we are equal to. So I'm going to say greater than or equal to -4. And we'll see if I can fit the rest. Because there's another rule I have to follow. Because did I circle a number like 5? 5 is greater than -4, but why did I not include that in my bold section? Well, that's because I get stopped at that +3, right? So I also need to tell someone that, hey, you can't go past 3. And am I allowed to equal 3? I'm not allowed to equal 3. So we could say that I'm greater than or equal to -4. However, I have to also, so I'm going to put and less than 3. Notice how I'm not saying I'm equal to 3 because it's an open point. Okay, this should be sort of familiar from last year. I'm not sure if you do the close points and open points from last year, but that's all the open point means, is that we don't write the equals to part. Now, as you can see, I struggled to fit all those words on a page. So what we want to do is write this in a more efficient way. So we're going to use an inequality. So we're going to use our little alligators symbols over here, right? Our greater than or less than's. So let's do that. First things first, we need to pick a variable, right? If I'm talking about a number and I don't really know what that number is, I just make a variable. And our go-to variable is always or usually just x. Let's see if I can write that a little bit. There we go. X. Now, what do we want x to do? What rules does it have to follow? Well, it has to follow that greater than or less than that we just talked about, right? So, if I want x to be greater than or equal to -4, I'm going to write my little greater than or equal to symbol, right? And I write -4. So right now, I can read this as two different ways. I could read this as -4 is less than or equal to x, or I can read it as x is greater than or equal to -4. All right? And then on the other side, I need to say that x is less than 3. So I say that x is less than 3. If you're not sure how to use the symbols, okay, the reason that I keep calling them like the alligators is because the alligator always wants to eat the bigger number, right? It wants the bigger meal. So the mouth is opening to the bigger number. So if it's between x or 3, well, I have to be less than 3, right? So x is smaller than 3, so the alligator is going to open the mouth to 3, in case you need a reminder on that. And there you go. You could write this differently. We could write this as like this. Let me see if I can make that a little bit closer together. There we go. You could write it like that. And it's still correct because if you notice that the inequalities are still opening to the same numbers, right? So this one right here is still opening to 3. This one right here is still opening to x. So we're saying the same thing on both ways to write it. But usually your test, and usually how we'll write it in class, is that we go least to greatest. So -4 is smaller than 3. So we just start with the -4. And then that way we just get used to writing our answers faster and checking them. Okay? So there you go. There's a quick review on how we do inequalities and how we do them on number lines. But now we want to take them to a graph, not just a number line. Okay, so this is where we go from like 8th grade and 7th grade math up to algebra. So, but we can use the idea of a number line to help us. And that's the good part. So let's see how that works. So now we want to find domain and range on a graph and also do that with lines rather than just points. Okay, so first thing is that the x-axis and the y-axis can be thought of as horizontal and vertical number lines. So if we were able to kind of follow along with the first example that we did with the number lines, well then you can just kind of think of it as doing a horizontal and vertical version of that problem. Okay? Let's start with the domain. If you remember from last time, the domain cares about x values. So we're going to go ahead and already say that we're on the x-axis. Okay? And like I said earlier, usually we're going to write our numbers from least to greatest, right? Just to go in order. So I can say that the domain, all we do is we're going to find the least to greatest. Now, let's think about what that means, okay? So if I go over to the graph, let's first find where the x-axis is. Remember that the x-axis is this axis right here. And let's look at what directions that's allowed to go. It's allowed to go to the left, and it's allowed to go to the right. Okay. So we know that the x-axis can go left and it can go right. But what we need to really know is when is it least and when is it greatest? Well, let's think about it. If I go to the left using my x values become negative, right? So this would be where I get my least or my smallest values because I get negative numbers on this side. Right? As you move to the left on the x-axis, you get negative numbers, so they're going to be smaller. As I move to the right, they're going to be greater because they are positive. So this would be where I get the greatest. Okay? So usually what helps students with domain and range is that instead of using least and greatest, we just use the directions. Okay? Because it's easier for us to just be like, hey, I need to look over here, and then I need to look over there, rather than always trying to keep up with least and greatest. So instead of writing least and greatest here, let's change it to what's going to be more helpful. We're going to change this to when you find your domain, we want to go from the left to the right. Because my x values can only go left and right, right? Because this is all still on the x-axis, which only moves left and right. Cool. Now let's think about how this changes for range. My range, if you remember from last time, only cares about y values. So we're going to use the y-axis. If I look at the y-axis, it only moves up and down. Okay? So again, if I want to go from least to greatest, as we said before, least to greatest, I'll just put greatest, right? Well, again, let's think about what does that mean in terms of the direction on the graph. Well, with y values, when do they get smaller? When do I get my least values? That's going to be when we go downwards, right? We're going to have my least values as I go down. So, we're going to call this the bottom. All right, so instead of least, we're going to change that to bottom. And instead of greatest, right, my greatest values are going to be at the top because that's where they become positive. Okay? As my y values go up, they become greater. So I move towards the top for them to become greatest. So what that means for us as our final notes is that to find the range, we're going to go from the bottom of the graph to the top of the graph. Okay? Because remember, domain wants x values and the range wants y values. So we only care about certain directions when we're looking at each one, right? Because x values can't go up and down. So whenever I'm looking at domain, I only care about x, I only care about left and right. But when I go to range, my y values only go up and down. So when I look at my range values, I don't care about left or right, I only care about bottom to top. All right, so we got the plan. We understand, what we're looking for, but let's actually put it into use because we might not know how to do that. So let's go to question 5. Question 5 wants us to find the domain and it wants us to find the range. So this is how we're going to do that. Domain uses what kind of values? This is going to be sort of the questions that you're going to ask yourself, okay? Domain uses what kind of values? Well, domain uses x values. So I'm going to put an x right in the middle. Okay? And then we got to remember that I want to look from the left to the right. And I already wrote my little inequality symbols, okay? So I got to find my left number and I got to find my right number. Well, I look at my graph and I just find that. I see that my leftmost point is right there. And my rightmost point is right there, okay? But now I need to know what their x values are. Like, what are their coordinate points? So if I write out the coordinate points for each of these, let's see. This coordinate point is -1, 2. And this coordinate point is 2, 0. Now, remember that domain only wants the x values. So when I look at these coordinate points, I have to remember that a coordinate point is always x, y. So I only care about the -1 and the 2. I only care about the first spot in the coordinate point. So then I just go back and say, well, my leftmost x value, right, the smallest x value that I can have is -1 on this line. Then I move to the right and I say, well, what's the x value I have all the way to the right? That would be 2. The only thing to check now is these inequality signs. Should I leave them as they are, or should I add the equals to? Well, remember from the beginning, we use the equals to if the point is filled in, right? But what do you notice about these 2 points? They're both not filled in. So we would actually just leave them as less than and greater than with no equals to. Okay, and that's basically how you find domain and range. All right, so let's continue and let's try to do the range part now. The only thing that changes is that instead of x values for range, we want y values. Okay, and instead of looking for left and right, we think, well, y values can only go what directions? They can go bottom to top, right? They can go up and down. So I'm going to say, okay, I need to find my bottom value, and I need to find my top value. Okay, so let's do that. Let's find our coordinate points that are at the bottom and at the top. So, if I'm trying to find the bottom value, that looks like that coordinate point right there. And if I'm trying to find the top value, it looks like it's that coordinate point. So again, we can find those coordinate points. They happen to be the same as last time. That happens sometimes. -1 and 2. Okay, so we have those coordinate points. But now, I don't care about the x values. I want the y values, the one in the second spot in the coordinate point, because I'm on range. So, I say, okay, well, what are those values? It's 2 and 0. But remember, I need to figure out which one is at the bottom. So if I look at the picture, I see that this coordinate point is at the bottom, so I'm going to use its y value, and that's 0. And then I go, okay, well, which y value was at the top? That was my other coordinate point, and its y value was 2, so I write 2. Again, last thing we have to check is, do I add those equals to on the bottom of these? How do I know if I add the equals to? I check, are the points filled in? If we look at the 2 points that we use, they are both not filled in, so I don't use equals to. And now we found domain and range of a line on a graph, right? So there's just a few things that we got to know. We got to know, okay, domain uses x, range uses y. That's step 1. Next step is, okay, if I'm using x values, what directions am I looking? Well, x's go left and right. And then after that, you just have to find your left point and your right point, right? So it's knowing that domain and range is what kind of value, then knowing what direction that value goes, and then just finding those points. All right, so let's keep up that strategy and see how we do. Okay, domain is what kind of value? It's x values. So I'm going to start by saying x. Okay, and then I ask myself, well, what directions do x values go? They can go left and they can go right. So I'm going to put my symbols, and I'm going to say left and right. And then I have to go through and find those left and right points. So I go, okay, well, here's my left point. Here's my right point. So what are the coordinate points there? That looks like it's -4, 6. And this one is 4, 6. Okay. So, again, I want x value. So we got to remind ourselves that coordinate points are x, then y. So I'm only looking at the first spot in the coordinate point. And I say, well, if I go all the way to the left, what's the x value? -4. So I'm going to replace that here. And then I go all the way to the right. What's that x value? I get 4. So I erase that and make it 4. Before we say we're done, we got to check. Do I add the equals to or do I leave it without the equals to? Well, are my points filled in? Yes. So I'm going to add equals to this time. And now I found the domain. All right, let's try it for range. Well, range uses what kind of value? It's going to use y values. Right? We want y values. And y values go up and down. But if we look at our graph, do we really move up or down? Not really, right? The bottom point is kind of the same as our top point. Like, what is the only y value that we have? It's 6, right? Because if I look at this coordinate point, well, it's -4, 6, so I'm at 6. If I look at this coordinate point, it's 4, 6, so y value is still 6. If I look in the middle, the y value is still 6, right? No matter where I check, the y value does not change. So we would just say y equals 6, right? That would be one way to write it. Let's move that over, actually. Y equals 6 is one way to write it. Or they could put it in the fancy brackets, like we did last time, since it's only one number, right? We can use the brackets when there's not too many numbers to write. We have to use the inequalities when we move on the graph, right? Because for domain, if I look at the x values, I had -4, -3, -2, -1, like all of those numbers, and all the decimals between them, like 0.5, 1.5, 2.5. I don't want to write all those, so I use an inequality. But because for the range, I only have one number, we just can write that one number. All right? Let's try 7. So again, we ask ourselves, domain is what kind of value? It's an x value. X values go what direction? They can go left and right. So I'm going to say I'm going to go left to right. Okay? And then I'm going to go find those left and right points. So what is the left point? It looks like it's right there. And my right point is right there. If I find this coordinate point, that is -5. Oop, that looks ugly. It's not much better. -5 and -10. And this coordinate point is 15 and 20. Okay. So what is the x value of my left point? It would be -5, and we're going to replace that. So we get -5. And then my right point has an x value of 15, so we replace that. And before we say we are done, I have to check, do I put the equals to or do I leave it? So if I look at my left point, realize that the point is open, so we're not going to change this symbol right here. Okay? We're going to keep it as just -5 is less than x. But if I look on the right, I do have a closed point there. So I need to say that x is going to be less than or equal to 15 because that point is included. It is filled in. All right. So now we could say our domain would be -5 is less than x, which is less than or equal to 15. Okay. And we are done with domain. Now we move on to the range. Okay, so let's kind of reset here. And we ask ourselves, well, I'm on range. So range uses what kind of values? Well, the range will use y values. And then I say, okay, well, what direction do y values go? They can go from the bottom. They can go from the bottom to the top, right? They go up and down. So then I go, okay, well, what are my bottom and top points? So I have a bottom point right there and a top point right there, right? I just look at where's the bottom of the graph, where's the top of the graph. And we find those coordinate points. So it looks like they're the same as last time. So let's write those back out. But remember, this time I want y values because I'm on the range. So the y value of my bottom point would be -10. So we go down here and we erase that. We get -10. And then the top point would be, well, let's find out. What's the y value? 20. And there you go. That is domain and range when you have a line. Okay? Pretty simple. Oh, wait. I almost forgot the last step. Don't forget this last step. Don't make this mistake. Am I done? Not yet, because I need to check, do I put the equals to or not? So if I look at the bottom point, we see that it's open. So we're going to leave it without an equals to. That's fine. But if I look at my top point, it is filled in. So I do need to put the equals to. And now we're done with that problem. Okay, so again, what are we going to do to solve these? You first say, okay, am I looking at domain or range? Because then that tells you if you're looking at x or y, right? So if I'm looking at domain, I say, okay, I'm on x values. Now that you know you're on x values, you say, what directions do I go? Well, x values go left and right, okay? And then we find out, okay, well, what's our left point and what's our right point? Once you have those x values, you got to check, do I put the equals to or not? And how do you do that? Well, it depends on if the point is open or if it's filled in, okay? And that's the basic idea. There is one thing that I want to talk about. So this is just an example of what it would look like on Alex. This is like basically what we just did. There's two endpoints. I think you can handle that. I'm not gonna add more time to that. That's basically what we just did together on the notes. But this is one that I wanted to show you because we did not get an example that had an arrow. Okay. What arrows do is basically they go on forever. Okay, so let's write that down. So arrows mean forever. They never stop. Which means if we look at this problem, let's say we're looking at the range and I'm trying to find my bottom point and my top point. Would this graph have a top point? No, because this arrow keeps going up and up and up and up and up. So we would never have a top. So what does that mean for our answer, right? We know that it will never stop. We know how to say that and understand that, but how do I write that down as an answer? So let's run through it real quick. Let's start with domain. So domain, I'm just going to try to fit it over here, uses x values. So I'm going to write x. Okay. And we know that x values can go left and right. There we go. Okay. So I can go from the left to the right. If I look at my graph, I have my left point right here. And then do we have a point that stops on the right? No. There is no point that stops on the right because this arrow is also moving to the right forever. So whenever you have an arrow that moves a direction forever, we're basically just going to erase that side of the equation, right? Or inequality. So because I don't have a stopping point on the right, I just erase that part of the inequality on the right. And we do the rest of the problem like normal, okay? So let's see. I still have a left point. Let's see what we can learn from it. The left point looks like it's at the coordinate point 0, 0. So the x value on the left would be 0. So I could say, okay, let's erase left. and I get 0. And before I finish, I say, do I need to put the equals to? Well, if I look at that point, is it shaded in? It is shaded in. So our final domain, let me make that 0 look a little bit nicer, would look like this. 0 is less than or equal to x. I don't have anything on the right because I never stop on the right. Okay, so we just put nothing. And that's how you would tackle that. So let's see how it affects the range. Well, range uses y values, and y values go up and down, right? So I can go from the bottom to the top. So let's find out where is our bottom point. So let's get rid of our domain markings here. Our bottom point looks like it's about right there. And do we have a top point, or do we go on forever? If we look at the top, there's an arrow going up, so we will never stop. And remember, like we did on the domain, if we don't have a stopping point, then we can't do that side of the inequality. So since I don't have a top, I'm just going to erase the top because I don't have one, right? So I erase the side that has top. And then I just have to find out, okay, well, what is my bottom point? What's the bottom y value? Well, the coordinate point at the bottom is 0, 0. And because I want the y value, I would say that's 0. So my bottom value is 0. And then I have to ask myself, do I put the equals to or not? And again, how do I check that? I see, well, is that coordinate point filled in or is it open? In this case, it's filled in. So make it an equals to. Okay, and that's the basic idea. The only thing that the Alex assignment will try to change is these arrows. Okay, sometimes they'll add the arrows. Basically, when you see the arrows, you just erase the side of the problem that it messed up, right? So in our example, we had to erase the right for the domain, and we had to erase the top for the range. Sometimes you'll have to erase the left, and you'll have to erase the bottom, okay? But just know that you just erase the side that the arrows kind of messed up. All right? Other than that, there shouldn't be any, like, curveballs or trick questions. It should be very similar to the notes. And yeah, just think about it as that left to right idea, bottom to top idea, and kind of just go through it the way I did it, and just get used to that, right? Because that's going to be the way that we kind of do it every year. So domain is X, that's left and right, and you'll just get so used to it by the end of the year, it'll be easy. Okay? So, if you got any questions, as always, send me a Canvas message, let me know. Other than that, good luck, and have a great day.